This is a review of the Chapter 4 PSAT questions. We're told in the problem that y is equal to 75. We can substitute that into the first equation. So we multiply 2 by 75 to get 150. And if we finish isolating z, the answer is 30. And since this 30 shows up in an isosceles triangle, we know that these two base angles are the same. So we can take 180 minus 30 divided by 2. This tells us they're both 75 degrees. Now finally x. This forms a linear pair. So we take 180 minus 75, and the answer is 105. That's what x is. 105. In this next problem, since RT and TU are congruent, we then know that triangle is isosceles. So these two angles, the base angles, are also congruent. Since our vertex angle 114 is given, I can take 180 minus 114 divided by 2 to find my base angles. They're both going to be 33 degrees. So if I consider this triangle SVU, I know two of its angles. To find the third, it's just 180 minus. And you might notice that 180 minus is the exact same thing you do to figure out x, because that's a linear pair. So it turns out a shortcut is that this answer x is actually going to be whatever 31 plus 33 is. Or you could do it step by step and work towards your answer. Either way, the answer is 64. We know two sides of this triangle, or two angles I should say, so we can take 180 minus 105 minus 35 to figure out the third angle. That means that x is 40 degrees. This forms a linear pair, so we take 180 minus 40, and we get 140 for y. But that's not the answer. Don't be fooled, because they want to know y minus x. So that is 140 minus 40. And the answer is 100. Aren't you glad you read carefully? Aren't you glad you looked at what the actual value they're looking for is? For this one, we have an isosceles triangle, and we have two similar triangles. We know that because they talk about the ratio of particular sides and side lengths. So I can write that ratio as 5x to 7x. They tell me that this entire length, BC, is 48, and I know that these two base angles are the same because the triangle is isosceles. More relevant, though, is that these side lengths are also going to have a ratio of 5x to 7x, whatever they are. So if I add those together to find the total length, I can get that 12x is equal to 48. If I divide, I get that x is equal to 4. And I'm going to plug this back in for each of those parts. They wanted the length of DC, that's 7 times 4, 28. If I was to write a congruency statement for this triangle on the left compared to the triangle on the right, I could do it like this, starting with A over to B and then over to D. And this triangle, I'm going to start with B, head over to C, because they said that these have the same value, and then head over to D. So to figure out if the ratios are the same, I have to look at the positions of each of these sides, or vertices, in the original congruency statement. BD, does that match up with DC? No, it goes from 2 to 3 and then from 3 to 2, so that's no good. BC, I guess over here, and then AC, well that doesn't work. It turns out AD and BD match up. It's the first and the third position. That's the correct answer. I can fill in missing angles, since the interior sum has to be 180. If I look at side BC, that is opposite the 32-degree angle. Which one is opposite the 32-degree angle in the other triangle? Here it is, DF or FD. And which one is opposite the AB, the segment AB? That's going to be the 90-degree angle. So it's opposite the 90-degree angle. Which one's opposite the 90-degree angle? That's this blue one here. So on the top, I want DF or FD. That rules out these two. And on the bottom, I want DE or ED. So this is the best choice. So if this one over here is 34, I know that 34 plus B plus C is equal to 180. And if I just move the 34 over, I'm left with B plus C is equal to 146. And I'm done, because that's the value of this expression, B plus C. You don't have to solve for B or C. We're told that ACD is a right triangle and that BE is parallel to CD. That suggests that there is a ratio between 3 and 9. And that same ratio exists between 5 and this larger side. We multiply by 3 to get 15. So if I have a right triangle, to figure out the hypotenuse, I can take the square root of 15 squared plus 9 squared. And that turns out to be 17.5. If you had a calculator, that would be easy for you also. To find the perimeter, I'm going to add up 17.5, 9, and 15. And I'm guessing it's the only one that ends in 0.5.